welcome to this session. In this session, first of all, let us discuss what are odds. Now, for an event E, P of E is the probability of happening of the event E, and we know that P of E is equal to the number of favorable outcomes whole upon the total number of outcomes. Now let us suppose in a random experiment there are n mutually exclusive and equally likely elementary events and m of them are favorable to an event E, then probability of the event E will be equal to m over n. Now let us discuss the concept of odds. Now the odds in favor of the event E will be equal to the number of favorable outcomes over the number of unfavorable outcomes. Now, this is the difference between the probability and odds. In case of probability, we take in the denominator total number of outcomes, but in case of odds, in the denominator, we take the number of unfavorable outcomes. Now here, the number of favorable outcomes is equal to m and the total number of outcomes is equal to n. So the number of unfavorable outcomes will be equal to the total number of outcomes minus number of favorable outcomes, that is n minus m. So the odds in favor of E will be equal to number of favorable outcomes, that is m, over number of unfavorable outcomes, that is n minus m. Now the odds against the event E will be equal to the number of unfavorable outcomes whole upon the number of favorable outcomes. So this is equal to n minus m whole upon n. So we can say that the odds in favor of the event E are m to n minus m, and odds against the event E are n minus m to m. Now let us discuss odds in terms of probabilities. Now we have calculated odds in favor of E is equal to m over n minus m. So m over n minus m will be equal to, now dividing the numerator and denominator by n and further solving it. Now here we know that m over n is equal to the probability of happening of an event E. So we can write it as the probability of happening of an event E over 1 minus the probability of happening of an event E. Also we know that 1 minus probability of happening of an event E is equal to the probability of the event not happening. So m over n minus m is equal to the probability of an event happening over the probability of the event not happening. That is, the probability of the success over the probability of the failure of the event. Therefore, we are getting odds in favor of E is equal to the probability of success over the probability of the failure of the event E, and in the same way we can get odds against the event E is equal to the probability of the failure over the probability of the success of an event E. Now let us discuss one example, and that is, what are the odds in favor of getting a number 5 in a throw of a die? What are the odds against getting 5? Now let us start with its solution. Now here the number of favorable outcomes, let it be m, of getting a number 5 in a throw of a die is 1, and the total number of possible outcomes, let it be n, in a throw of a die is 6, and the number of unfavorable outcomes, that is n minus m, is equal to 6 minus 1, that is equal to 5. Now the odds in favor of getting number 5 is equal to the number of favorable outcomes, that is 1, over the number of unfavorable outcomes, that is 5. So the odds in favor of getting a number 5 are 1 to 5. Now the odds against getting a number 5 is equal to the number of unfavorable outcomes, that is 5, over the number of favorable outcomes, that is 1. So the odds against getting 5 are 5 to 1. Now let us discuss how to solve some of the questions of probability using permutations and combinations. As we know that permutation is an arrangement in a definite order of a number of objects taken some or all at a time, and if each of the different groups or selections which can be made by taking some or all of a number of things at a time, irrespective of the order, is called combination. Now let us discuss an example, and that is, the last 6 letters of the alphabet are written down at random. What is the probability that there are 3 letters between the alphabet U and V? Now let us start with its solution. Now let the 6 positions be denoted by 1, 2, 3, 4, 5 and 6, where U is kept at the first place and V will occupy the 5th place to have 3 letters in between them. Now consider the same 6 positions again. Now when U is kept at the 2nd place, then V must occupy the 6th place to have 3 letters in between. Now U and V can also interchange their positions in 2 factorial ways. Thus, U and V can take the required positions in 2 into 2 factorial, which is equal to 4 ways. Now, out of the remaining 4 alphabets, three can be selected in 4C3 ways. Now these 3 letters and one other can give 3 factorial into 1 factorial arrangements. Therefore, the number of arrangements in which there are 3 letters between U and V is equal to 4 into 4C3 into 3 factorial into 1 factorial. Now the total number of arrangements in which 6 letters can be put is equal to 6 factorial. Hence, the required probability is equal to the number of favorable outcomes over total number of possible outcomes. So the number of favorable outcomes is this, that is 4 into 4C3 into 3 factorial into 1 factorial, and the total number of possible outcomes is 6 factorial. So the required probability will be equal to 4 into 4C3 into 3 factorial into 1 factorial whole upon 6 factorial. Now 4C3 is equal to 4 factorial over 3 factorial into 4 minus 3 whole factorial, which on solving will give 4. So this is further equal to 4 into 4C3 is 4 into 3 factorial is 3 into 2 into 1 and 1 factorial is 1 whole upon 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. On solving, this will give 2 upon 15. So the required probability is equal to 2 over 15. So in this session, we have learnt about odds and the problems of probability involving permutations and combinations simultaneously. So this completes our session. Hope you all have enjoyed the session.